Today we're going to talk about equations of circles, so that if I give you pictures like these two, you would be able to write an equation that would show you any point that would be on that circle on that graph. But in order to actually write the equation of the circle, there are two things that we're going to have to keep in mind. So we're going to start actually by going all the way over to what we call the distance formula. And we are going to need this in order to find a few elements of our circle. So the distance formula is definitely one that can be memorized, but you can actually find the distance formula using the best formula, the Pythagorean theorem. And this is why. We know that the distance between these 2 points can be physically drawn on a graph like this. But you could also take a roundabout way and go all the way over on the x-axis here horizontally and then up on the y. And notice that what we've just formed is a perfectly beautiful right triangle. Now, since we have a right triangle, that means that we can find distance using the Pythagorean theorem, where a squared plus b squared equals c squared. And a squared and b squared represent the legs, the values of the legs of the right triangle, those two things that form that 90-degree angle, squared to give us the hypotenuse, in this case, our distance squared. But of course, we don't want to have to find this first. So we're going to make a general statement about this horizontal leg. In order to find the distance of this leg, I could physically, of course, count how far over it is. Or I could just say, well, the distance from here to here is the difference between this point and this point. In other words, it's the difference between one of my x values and the other x value. So one of my legs is just x2 minus x1, the x values in that point. And if I wanted to talk about the change in y, the same sort of thing is happening. I'm going from 1 to 3. In other words, I could take 3, subtract 1, and I know I went a distance of 2 units. Well, that's just doing y2 minus y1, our y elements of that coordinate. So let's just write y2 minus y1. And put that in place of b. Now that's going to give us, of course, our distance squared. Now if we want to have just our distance, I can then take the square root of both sides, and that will give me a distance formula, where distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now be careful, you need subtraction signs inside the parentheses. Don't miss your squares, and watch that you have a plus sign between them. That is the core of the Pythagorean theorem. So we're going to use this distance formula, and it is particularly, of course, useful to find distances, which we often refer to as lengths. And when we're dealing with a circle, the lengths in a circle are usually things like the diameter and the radius. So this might be a helpful formula if you are missing a diameter or a radius and all they give you are 2 points, which you can then convert to a length. But we're also going to be using the midpoint formula. The midpoint formula tells us what is the exact middle of this line. Now I could kind of just throw a guess in. It looks like it's about here. But of course we don't want to guess in algebra. However, if you kind of break this down into its pieces, it's basically half the distance that we go horizontally will give us this part of it, and half the distance that we go vertically will give us this part of it to give us the final midpoint. In other words, we want the average of the x values and the average of the y. In formula form, that means that if you have a point x1, y1, and another point x2, y2, you can find the midpoint by doing the sum of the x's over 2 to get the average of those, and the sum of the y's over 2 to get the average of the y values. In this case, that would mean I do negative 2 plus 4 to get x1 plus x2, and that would give me a value of 2. 2 over 2 will give me 1, so I'd have a point 1 for the x value. And for y, I have y1 is 1, y2 is 3, so 1 plus 3 over 2 will give me my y value. 1 plus 3 is 4, over 2 is 2, so I have the value 1, 2. And if I look at my graph, that certainly makes sense. Even my guess is exactly at 1, 2. This midpoint formula is going to be particularly useful when you're looking, of course, for points. That's what it does. And in a circle, the main point that we focus on is the center. So if you ever need to find a center of the circle, it would be good to consider the midpoint formula. But let's get to the actual equation of a circle. Now, the equation of a circle can actually be described using the distance formula. Because when we're talking about a circle, what we're really talking about is all of the points that are an equal distance from one center point. And the distance that's described is, of course, our radius. And we can just label this center point something just so we have a value. We don't want to call it like a literal center point at this stage because we want to be able to drop things into there later. So let's give it the variables hk. And since I know that all of those points will be equal distance, what I can just say is if x and y are just a point on the circle, they are always going to be equal distance from the radius or from the center no matter where I go because they're restrained by that radius. So our distance remains consistent, or our radius squared is going to be consistent. And I can actually drop these into the distance formula or form of the distance formula. And I know that it's forming a true equation. So I'm going to draw out my general distance formula where d squared, or in this case r squared, is equal to 1 point, like with the x values subtracted squared and the y values subtracted squared. So here I'm going to have x minus my h value, the center x value, and y minus the k value. Now this will provide that equation of a circle. And in order to fill in an equation of a circle, you're usually going to have to find then what the radius is, and you'll have to find what hk is, so that you can leave x and y blank to represent all of those possible points. So let's look at what this equation of the circle would be. Here, don't try to do this angled one like I did. It's going to give you a ton of extra work. Rotate your radius around to something that's easy to find. We can then look at here how far away are these 2 points. We've got 1, 2, 3, 4 points away, so my radius is 4. HK is that center point. Watch your negatives. We are at -1, 3. So I can place those into my formula to have a filled-in equation of the circle. Radius will be squared, so we'll have 4 squared is equal to x minus my h value, or -1. Now since I've subtracted a negative, I'm just going to change that to a plus sign. And I'm going to add y minus k squared as well. And since our k value is 3, it'd be y minus 3 squared. Of course, you can write this then as 16 is equal to this, or if you'd rather, it is also okay to do 4 is equal to the square root of the other side. This is less common. Usually you're going to see it written as like the 4 squared, but just be aware that this is an equivalent equation, so upon occasion you will see it written this way. That's the basics of the equations of circles.